Hello, guys, and how are you? Welcome back to Math Zone African Motives. Today, I want us to look into grade 12 physical sciences. We are going to be looking into a topic that we refer to as momentum, impulse, and collisions. So, what I want us to do today is I brought you some notes. So I'm going to give you notes and I'm going to explain some concept related to those notes. And then after, we are going to do an example of practice question section where we are now going to check comprehension in everything that we would have done. So we are also going to involve important definitions as well as explaining important laws and concepts that has to do with momentum, rate of change of momentum, Newton's second law in terms of momentum. So without wasting time, let's get started. So you would see that uh, in the field of mechanics, momentum and impulse, or what we refer to as momentum and impulse, are the key concepts that are used to analyze the motion of objects, especially when forces act over short time intervals, such as during collisions. So, in actual essence, what we are saying that these concepts they help us to explain how and why objects change their motion. They help us to explain how the how part as well as the why part objects gets to change their motion within a short time interval. Okay, let's begin by defining what we refer to as momentum. Maybe we can start getting an idea of what we want to say. So you would see that the question define momentum in words, or else state momentum, state what momentum means in words will always come in a lot of your exams, or else is going to be a familiar question in your exams. And how you are going to define this is going to be like this. We know that whenever we have got a mass that is moving, like for example, whenever we've got a car that is moving, or else we've got a bicycle that is moving, or a trolley that can be pushed, mean to say a trolley that is moving. Whenever, let's get to say we have got an aeroplane, whenever we've got a tennis ball that is in motion, whenever we have got a football that is motion, whenever maybe let's say you kick that football, or else someone uses a racket to actually hit on the tennis ball, or someone else throws a handball, we actually have our objects to be having momentum. So, what is it that we define momentum as? Momentum is what we refer to as mass in motion. Momentum is what we refer to as mass in motion. So, what is it that I'm saying? I'm saying that momentum is a vector quantity that is defined by multiplying, or else that is defined as the product of an object's mass and its velocity. So momentum is represented by the letter P, and it is given by mass times velocity. So since we all know that velocity is a vector quantity that has got both magnitude and direction, also as well momentum is also a what, a vector quantity. It has got both what, magnitude and direction. So in simple words, you might define momentum as mass in motion, or else you would explicitly say that momentum is a vector quantity. What this means is that it has got both what, magnitude, or else size and direction. That is what it means. Momentum is a vector quantity defined as the product of an object's mass and its velocity. This question is most familiar when it comes to grade core physical sciences. They like it a lot. So you are going to meet this question a lot. So you need to master this definition where we are saying that momentum is a vector quantity that is defined by the product of the object's mass and its velocity. And momentum is represented by the letter P, where momentum is given by mass times velocity. So momentum would be P equal to M times V, just like that. Where M would be representing mass in kgs and V would be representing velocity in meters per second. And then P would be representing momentum, which is the product of kg and meters per second. So its SI unit becomes kg meters per second. And then we need to look into the characteristics of momentum. As we have mentioned, we have said that momentum is a vector quantity, which means that momentum has both magnitude as well as direction. Whenever you state or else you want to fully describe momentum, you need to actually get to describe or else determine its magnitude, which is its size, as well as its direction. Where is that momentum directed towards? Is it towards the right, towards the left, up or down, to the east, to the north? You need to state its direction. So we are saying that momentum has got both magnitude and direction, since we have simply said that momentum is a what? Is a vector quantity. And also, objects with larger mass, whenever we have got a larger mass, as well as whenever we've got a greater velocity or else a higher velocity, it simply means that we would have a what? A greater momentum. Whenever we've got a larger mass or else when we have got a higher velocity, just know that you'll be having a greater momentum, which simply means that also when you have got a smaller mass, where you have got a smaller mass, or else where you have got a what? A lower velocity, then the momentum would be what? Would be small. The momentum would be relatively what? Small. So in simple essence, we are saying that momentum being represented by the letter P is directly proportional to the mass of the object. So the graph that you can plot of momentum against mass, it will simply be a straight line graph, which represents directly proportional in between these two. And also, momentum being represented by the letter P against velocity, if you plot momentum against velocity, you would also have a straight line graph, which represents that momentum is directly proportional to the velocity of the object, as well as the momentum would be directly proportional to the mass of the object. So you need to know these relationships. At some point in time, they would say that describe the relationship between momentum and mass, or else momentum and velocity, in terms of a graph, or else using a graph. So these are the graphs that you can draw, and then you can later explain what these graphs they mean, to say that momentum is directly proportional to the mass of the object, as well as momentum is directly proportional to the velocity of the object. So that is simply what you can actually get to do there. So those are the two most important characteristics of what? Of momentum. Also, the other thing is, whenever the object is at rest, when an object is not moving, let's say that you have got an object that is stationary or else it's at rest, just simply know that because there is no movement, there is no motion, there is no velocity. Therefore, the momentum of that object would be zero. Since velocity would be equal to zero, momentum will also be equal to zero. So for stationary objects or else for objects at rest, momentum of those objects is equal to zero because we said momentum is mass in motion. So we need to have our mass moving. We need to have our mass in motion. So whenever our mass is stationary or else is at rest, it simply means that there is no momentum. And also, this will translate to the fact that, for example, a fast moving car has more momentum than a slow moving bicycle. This translates to this characteristic where we said whenever we've got a higher velocity, we will definitely have greater momentum. So this is where we are saying a fast moving car has more momentum than a slow moving bicycle. And then a truck and a car moving at the same speed, you would have the truck having a greater momentum due to its larger mass than the car. So this would also directly translate to that characteristic to say that whenever you have got a truck that is in motion, as well as whenever you have got a smaller car, where now you would simply have a smaller car. Pardon my drawing. I'm just using my elementary school drawing. Yes. So we are saying that whenever you have got a truck that is moving at the same speed, if these two, they are moving at the same speed, and then you have got a truck, and then here you have got a small car, due to the larger mass of the truck would be having a greater momentum than the car. You need to understand and actually get to know that. So with these characteristics of momentum, one thing that I would actually leave you with, or else that I would actually give you as an assignment, is to go and read and also investigate on more examples of what? Of how momentum differs in different scenarios. Like, for example, we say that whenever we've got a fast moving car and then a slow moving bicycle, a fast moving car would be having more momentum. And then whenever we've got a bigger truck and a smaller car moving at the same velocity or speed, the truck would have a greater momentum than the car. That is the reason why when the truck collides with the smaller car would have more damage than the truck, because this truck is actually having or carrying a greater momentum that would actually lead to crashing this car. That is the reason why. So you need to understand those principles. Now, I now want us to look into something that we refer to as change in momentum. So whenever an object's velocity changes in magnitude, which is its size, or else it changes direction, you need to now understand that also the momentum of that same object will change. So let's say, for example, the object's velocity, the initial velocity, was equal to 2 meters per second towards the right. And then now the object starts accelerating, and then its velocity increases to 4 meters per square second. Just also moving in the same direction. Just know that due to the change in velocity, which is v final minus v initial, giving you 4 minus 2, since they're in the same direction, it will be 2 meters per second. That is the change in velocity. This change in velocity will simply translate to the change in momentum. So whenever we have got a change in the size or else the magnitude of the velocity of an object, also know that we will have a change in the momentum of the object. Also, let's say that the object was moving towards the right, and then it turns and then it starts moving towards the left. We can see that the velocity of the object initially would be different from the velocity of the object finally, because we are saying now if I'm to take going to the right to be positive, it simply means that going to the left would be negative. So my final velocity would be a negative velocity, whilst my initial was a what? Was a positive velocity. So this would translate to a change in velocity. Okay, fine. Let me give a practical example. Let's say, for example, a car is moving at 2 meters per second. A car is moving at 2 meters per second towards the right. And then it turns, it starts moving at 2 meters per second towards the left. What becomes the change in velocity? The change in velocity will now become final velocity minus initial velocity, which will translate to final velocity. If I'm to take going to the right to be positive, it becomes negative 2 meters per second. And then minus my initial velocity is just positive 2 meters per second. So the change in velocity becomes negative 4 meters per second. Due to this change in velocity, there is going to be change in what? In momentum. How so? We know that momentum is given by what? It is given by mass times velocity. And then if I'm to have initial momentum, it will be mass times initial velocity. If I'm to have final momentum, I would be having mass times what? Final velocity. So my change in momentum would be given by final momentum minus what? Initial momentum. Where this would actually simply translate to, this will simply translate to change in momentum would be my final momentum is now mv final minus mv initial. So you can see that mass is constant, so it will be final minus initial. So here I'm now saying mass times what? Change in velocity. So whenever we have got change in velocity, we are definitely going to have change in momentum. Now, an interesting part is that we are always going to assume that an object's mass remains constant. We assume that the object does not break, or else the object does not change to become relatively smaller in such a way that the mass of the object changes. So we are going to always assume that the mass of the object remains constant. The object does not break. It simply stays intact, having the same mass. So that whenever we've got change in velocity, which is given by final velocity minus initial velocity, we are definitely going to have change in momentum, which is given by initial momentum minus final momentum minus initial momentum, which translates to what? Mass times final velocity minus mass times initial velocity, which is simply the same as mass times change in velocity. So I will need you to fully understand this principle of what? Of change in momentum, where we are saying that whenever an object's velocity changes, either in magnitude, which is its size, or else in direction, just get to know that its momentum will also change. And always assume that an object's mass remains constant during a collision, unless given otherwise. If that is the case, now I want us to look into some example question so that we can actually get to start checking comprehension into whether we understood what we have been defining and what we have been explaining. So I've got some questions that I brought to you today that I want us to help each other to solve. For example, we have got question number 1. It is saying a car has a momentum of 20,000 kg meters per second. What will the car's new momentum be if it was, or else if its mass is doubled by adding more passengers and a greater load, and it travels at the same velocity? So we know that momentum, we said momentum is equals to mass times velocity. And here they are saying that the momentum is equal to 20,000 kg meters per second, given that the mass is m. So this is the initial scenario, which is initial momentum. What becomes the final momentum? If the mass of the object is doubled, we have got 2m, and the velocity remains the same. You can simply see that our final momentum becomes 2 times mv, which is 2 times the initial momentum. So definitely our momentum is actually going to double. So our final momentum is going to be 2 times the initial momentum. So we are going to see that our momentum is also going to what? To double. It is also going to double. So our final momentum will simply be equal to 2 times 20,000 kg meters per second. That is what you are simply supposed to do there. So allow me to take you back and let's try to do this neatly so that others can actually get to follow, because most people, they get lost there. So we do not want to lose anyone. So by that, I would actually come to say our initial momentum is equal to m times v, and this is equal to 20,000 kgs meters per second. And then now they are saying the final momentum is now equal to 2 times, or else let me say, they actually said that our mass now has been doubled to become 2m, but we are still having the same velocity. Therefore, our final momentum would simply become what? 2m times the initial velocity, which will give you what? 2 times m times v, which is the same as just saying 2 times the initial momentum. So you would simply see that the final momentum would become 2 times 20,000 kg meters per second. And that becomes 40,000 kg meters per second. That was going to be the answer for what? For question number 1. Now let's look at question number 2. What will the velocity be if the momentum is 60,000 kg meters per second and the mass of the car is 2,000 kgs? So it's simply the same thing. Momentum is equal to mass times velocity. And they want us to determine the velocity. Given that the momentum given it's 60,000 kg meters per second. And here we have got a mass of what? We have got a mass of 2,000 kg. What we do not know is the velocity. What we do not know is the velocity. So now we can simply divide throughout by 2,000 kgs. We cancel out this side. We divide by 2,000 kgs. We will cancel out the kgs. We'll be left with meters per second. So you would see that the velocity itself, because here we are looking for what? The velocity. The velocity would be equal to what? 2,000 into 60,000, it will be equal to 30 meters per second. And the velocity would be in the same direction as what? As momentum. So you can say 30 meters per second in the same direction as the momentum. Why is it the same direction as the momentum? because we can see that this is a positive and our momentum was also a positive. So they carry the same direction. After I've said that, let me just get to rub through this on top. If you want to actually get to revise, you can pause and rewind the videos. Me rubbing, it makes my work a little bit neat, and also you can actually get to what to see through the questions clearly. Okay, fine. Now the question is saying a truck has a mass of 6,000 kgs. Let me just get to take this up. A truck is a mass of 6,000 kg and travels at 80 kilometers per hour. How does the momentum change if the truck is loaded with 1,000 kg and then travels at 60 kilometers per hour? Okay, fine. Here we are going to assume that initially the truck is moving in that direction. We are going to assume that the truck is moving in that direction. Just allow me. Ish, my drawing is actually nearly perfect. I can actually get to see and hear people whisper and laugh at my drawing. But anyways, it's not a big deal. I'll try to imagine a truck that I've seen in my life and also use my elementary drawing skills to represent that truck. Right. At least this time around I've tried. So let's assume that this is the truck that they are referring to. And they're saying that this truck has got a mass of 6,000 kgs and it is traveling at 80 kilometers per hour. So assume that it is in this direction. And then now they're saying, how does the momentum change if now the truck is loaded with 1,000 kgs and then travels at 60 kilometers per hour? So the truck, its mass is 6,000 kgs. Now they get to load it with 1,000 kgs on top. So it simply means that the truck now, so just give me a second. I can see that I need to power my things. Okay, fine. Everything is fine now. Pardon me for that. So we are saying now the truck is now loaded. We want to load that truck now. Don't mind my drawing. I'm just going to give a representation of whatsoever that they're saying. So they load it with a mass of what? The mass is 1,000 kgs. Its own mass is 6,000 kgs. And now, because it is now having a load, it starts moving at a lower speed, which is 60 kilometers per hour. Now they want us to determine what? The change in momentum. So how do we tackle this question? So what we simply do is this. We need to find the initial momentum. So the initial momentum is given by the mass times the initial velocity. Or else, let's say it is given by the mass times velocity initial. I'll say mass times velocity initial, which is, what is the mass there? 6,000 kgs. And then the velocity. So we know that velocity is measured in meters per second. So we need to change 80 kilometers per hour to what? To meters per second. So we divide 80 by 3.6 to give us 22.22 meters per second. So just know that the conversion factor from kilometers per hour, it's 3.6 kilometers per hour. So you just divide by 3.6 there. So you would get 22.222 meters per second. And what becomes our initial momentum? So allow me to use my calculator, whilst you are also using your calculator as well. So we are saying 22.222 times 6,000. That gives you 133,332. So our initial momentum was 133,332 kg meters per second. And then what was our final momentum this side? So you would see that it is given by mass times velocity final. And that becomes what? Our mass now, it's now 6,000 plus 1,200. And then what is our velocity now? 60 kilometers per hour. You just say 60 divided by 3.6. That gives you 16.66. So you just say 60 divided by 3.6. It gives you what? 16.666 meters per second. So you need to convert kilometers per hour to meters per second. Kilometers per hour to meters per second. How do you do that? You use this conversion factor, which is 3.6 kilometers per hour. At some point in time, they give you this conversion factor. At some point in time, they don't. So just get to know it. You need to know it by head. So here you would get 16.66 meters per second. By doing that, this becomes 7,200 and then times 16.666. This would be equal to. So that would simply be equal to, if we multiply 7,200 by 16.666, I would get a final momentum of what? I would get a final momentum of 120,200 kg meters per second. Now, what am I looking for? I'm looking for the change in momentum. I'm looking to say how does my momentum change? Change in momentum would be equal to final momentum minus initial momentum. My final is this one. So I would actually get to think that they are all in the same direction. So I'll take to be positive, both of them. So this becomes 120,000 minus 133,332. This being in kg meters per second. So the value that I find there, if I do that, you would see that you need to find a value of 13,332. 13,332 kg meters per second. So definitely it will be a negative. So this value is going to be a negative, which shows that our momentum has decreased by what? It has decreased by a factor of 13,332 kgs meters per second. So we are saying the change in momentum, that change in momentum is a negative 13,332 kg meters per second, which means that our momentum is decreased by that factor. So that is simply how you actually get to apply the definition of momentum as well as the principle of change of momentum to answer questions. So that is it for this first video. Let's meet in our next video when now we dive deep into rate of change of momentum as well as look into Newton's law of motion, which is second Newton's law of motion in terms of momentum. Thereafter, we then get into impulse. So let's meet in our next video.